getting recorded, right?
Yeah.
Oh, yeah, we can start. You can start with the first question. It was like longest uncommon sequence. We are given two strings and we need to find the longest uncommon subsequence of these two strings. And the longest uncommon subsequence would be defined as the longest subsequence of one of these strings. And this subsequence should not be any subsequence of the other string. A subsequence is a sequence that can be derived from one sequence by deleting some of the characters without changing the order of the remaining elements. Trivially, any string is a subsequence of itself, and any empty string is also a subsequence of any string. Okay, the input they'll give us two strings, and output needs to be the length of the longest uncommon sequence. If it doesn't exist, we need to return -1 in that case. So let's say here you have ABA and CDC. So you can see none of the characters of this matches with this. I mean, they both are entirely different. So the longest one would be initially we can start with A, then AB, and then ABA. ABA would be the longest one. So this is the length of that. And here again, none of them matches. So 3. Here you'll have -1 because these two are the common, not the uncommon ones. And both the strings will lie between 1 to 100. And the latest will be only from A to Z, which will appear in the input string. Yeah. Yeah. So any queries on the question?
Yeah, Shashank, like if we have an input like A, B, C, A, and
Okay.
another string A, B, C, so what would be, you think, the uncommon subsequence?
I think.
Because I was not clear about that part.
Yeah. What is first string is?
A, B, C, B.
Okay.
A, B, C, B, yeah. And the second will be just A, B, C.
I think it will be AC.
B. No, but
AC, AC.
AC is not uncommon. How? Why AC?
See,
Because
the common subsequence is like maybe A, B, C, right?
Yeah.
Right. So, but when it says uncommon subsequence, what I was under the impression is whatever is remaining out of the lowest common subsequence, that will be the uncommon subsequence.
Okay, okay.
I think
this is my understanding. I might be wrong. I'm just throwing some my thoughts over here. So you people could correct me.
This will be
Yeah,
ACB.
So what do you think? Yeah, say, go ahead.
I think answer for this will be ACB.
ACB.
Why I think so? Because ACB is not the subsequence of ABC, and that's the longest one.
Okay.
If you take ABC, then that will not be possible. If you take ABCB, I think ABCB can also be the answer.
Answer will be ABCB.
Yeah, ABCB will be the answer, right?
Yeah. See here, what we have to do, if the words are equal, both the strings are equal, then in that case, you need return -1. I mean, exactly if they are equal by character wise. If they are different, then just take the longest length, whichever you are having.
Yeah, right.
No, that is okay, but I think Arpit was saying, right, ABCB, right, Arpit? Yeah. Actually, means if it is not a common subsequence, right? If it is not a common subsequence, then only it is a longest uncommon subsequence, right?
Yeah.
In the ABCB, we can always get ABC at least as a longest common sequence, right?
Okay. So I think like the any part of so for example, we pick up some subsequence, in this case ABCB. So we don't bother about part of ABCB being the subsequence of another string. The entire string shouldn't be the subsequence of another one. That's what I understood. Maybe I can be wrong.
The question doesn't make any sense.
Yeah. I think it's
it's
that is why
difficult to
4,000.
interpret. Yeah.
Yeah.
That is why there are 4,000 downward.
I think it might be just warm-up problem.
Sort of, yeah, but you never know. If this comes up somewhere, we will be, like.
Even for the warm-up, I mean, this problem, it really looks confusing to me.
Yeah, the examples are also like they've given either none of the strings are common, characters are common, and rest every character is common.
You can see this.
Yeah.
Not really clear what exactly They won't say here in this question.
Yeah.
This I'll do later.
No, don't do that. Yeah. So, okay, no problem. So
Yeah.
let's go with the approach.
Mine was like just I was checking if they are exactly similar, then I'll return -1 in that case. Else, if they are different, whosoever is having the greater length, I'll return that.
Yeah, that makes sense here.
I got the length of first and second, just comparing whichever is greater, and I'll check whether B can be found in. I mean, if B is a substring of this, it will return the first index from where it is starting, and if that is greater than 0, then it will return -1, or at last, none of the conditions suffices, then it will return the length of A. But yeah, it's not that bit clear in this. Any other approach in this?
Oh, I think the only difference.
Yeah, that is at least very easy to implement and understand. So
Yeah.
actually,
Yeah.
the brute force the way they have actually described is slightly difficult to understand, and they are using too much of extra space there. Yeah.
So can we relate this question with the common subsequence problem, or this one is completely different?
Yeah, we were trying to find a correlation there between both of them, but it seems like this is slightly different. It's different to visualize actually what it is.
They are checking, I think, here whether each characters can come or not, right? That because of that 2 is coming, isn't it? I mean, whether the character can come, whether we can include the character or we can't include. So for every character, there are 2 possible choices. The brute force, what I'm saying. And then the x and y are lengths of string A and B. And so they'll generate these many subsequences out of the, I mean, they'll generate the 2 k power x subsequences from here, 2 k power y subsequences. And among them, they are generating the max, whichever.
So whatever is the maximum non-subsequence, yeah.
Yeah. Yeah, it's not that. Okay. Yeah. Shall we switch to next or any queries in this?
Okay, let's move on.
Yeah, move on. Yeah. Nothing to discuss here.
This is a flattened nested list iterator. We are given a nested list of integers. We need to implement an iterator in order to flatten it. Each element is either an integer or a list, whose elements may also be an integer or list. Okay, so like you can list within list, and inside the list you'll always have an integer, or you can have integer. So after flattening, you'll get this. So they have given you certain functions to implement according to them, like has next function and next function is there. Yeah, I mean, question is like language depend, like which data structure I think they are trying to check would be more apt for this. Yeah, any queries or approach in this?
Can you just go back to the question, starting with the question?
Yeah. Should I read once more?
No, I'll just read it myself.
Okay. Hash map.
Yeah, so when we go, let's say when we go deep down, we have to remember, how we're gonna go back, right? So that would make me think that using the stack.
Yeah, I use the stack to solve this.
Yeah, I used queue for this. Okay, that's the double-ended queue I used. Okay, stack. How do you proceed?
So I use a stack, and during the constructor, I post all the elements to the stack. And when inside the has next, so I actually check that if the top element is just an integer, leave it. If the top element is not is a nested list, then flatten it and push to the stack again. And when the next is just called, so I know that the top element will always be just an integer. So just return the top element from there.
So next will behave like, go ahead.
So I kind of doing the same thing too, but now I think that we don't need to put everything on the stack, because we only need to put like, you know, the next pointer to the stack. And then we have the current pointer, which is traverse, use that pointer to traverse down. And then, you know, when that pointer become null, then the stack is not empty, then the next element have to be the one on the stack. In that way, we might keep the stack size small.
So, but then you are saying you're just going to put a single element on the stack?
Yeah, when necessary, I need to put that whenever I'm thinking like go down the tree, right? So if I go down, if there's a branch, and then I have to remember I put, you know, the right subtree to the stack. So I traverse down the left subtree. And then, you know, if I see a branch again, I have to put that right subtree on the stack and keep going down on the left.
Mm-hmm. So, but what happens if you have a nested list in it?
Yes, that's kind of the branch, right? If I have nested, that means, you know, I have one branch, I save one on the stack, and then I go down. And if I have branch again, I put the next one on the stack.
Mm-hmm. I think that would be a very optimum way of doing it. Yeah, but okay, could you share your approach also? Is it possible?
I'm doing the same approach as Widget mentioned, but now I'm thinking, you know, I just think about that way, so I don't have code yet.
Oh, okay. So just brainstorming on that. Yeah, that would be a good one to do, but I'm not sure how to implement that. So I was a bit confused. So I also tried the same way what PS was talking about.
Yeah.
Yeah. So
yeah, he is taking nested list as a branch of another node, right? I mean, how is inserting tree here? Like I mean, how is?
See, what he's saying is whenever he goes to this list, okay, and the way I was thinking as well as PS was saying, you actually first put all the whatever the high level strings or nested strings in that stack, starting from the backside, right? And
exactly. Yep.
Yeah.
Starting from the back, first put all the element to the stack, and inside the has next, check that what is your top item, whether it's an integer, flat, normal integer, or a nested list. Yeah, okay. If it's an integer, then do nothing, just return has next true. And if it's a nested string, then actually flatten that that nested string, push back to the stack again.
Mm-hmm. Yeah. So I think because in this case, what we are doing is we are having all the data on the stack, right? So, but what Leon was suggesting is just pick up one. Okay, if it is a nested, keep on doing that. You know, keep on flattening it. Once that is over, go and pick the next one. That also makes a very good approach, you know, and that is what should be done, because we don't want to have all the data like flatten a whole thing. I don't think that is a good way of doing it, because that is very easy, right?
Yeah, I think it's a optimization. I think what Len just explained that, I think that looks like that's doable. So instead of actually pushing all the element up front into the stack, so just actually push the first element to the stack, and keep the list with the current position. And inside during the has next, what we are doing right now, what I'm doing right now. If in that case stack is empty, then check that if the list index is reached up to the end. If it's not, then pick the next element, push to the stack, and process that. If it's a nested list, unflatten it, push back to the stack. That only one element.
So, but in that case, what Leon was suggesting, if you're saying the same way, but we might need more than one stack. Single stack won't be sufficient. Either we need a recursive function to do that, or a stack.
We only need one single stack, right?
One stack should be enough. I mean, the stack what we are using right now we are pushing all the element to the stack. But what he's suggesting, if I understood correctly, so we just need to push only one element to the stack. And if we need to process or unflatten that, just unflatten only one element. And rest of the element will stay inside the original list.
The stack could contain multiple elements, but like to visualize it, we can think it like a binary tree, right? And we do the iterative in order binary tree.
But in order binary tree requires, first we have the main stack, and then the binary tree itself will have another stack, right?
No, recursive stack. Iterative binary tree. So we create a stack, right? And we traverse down the left, and we save the right subtree on the stack.
So the right binary tree also requires a stack, right?
Yeah.
Yeah, the right subtree here represent like a sublist in this problem.
Mm-hmm.
So that way we can visualize it, and we can, I think we can do the same thing.
It makes sense. But I was thinking like we might need two stacks in that case. One for the binary tree and one for the main tree. That is what my understanding is, yeah.
Because you have the current pointer, right? And the stack only contain the next pointer. If you run out of, if the current pointer is no, then you pop the one from the stack. So that's why we use the stack, because the stack can contain multiple elements, right? Multiple pointer on there.
Okay. So you're trying to say that the main list, you are just going to use a pointer, but whatever the list you are going to put in the stack will be the one which you are trying to actually flatten it, the current one. Okay, makes sense. But I've never seen that implementation anywhere in these discussions.
Yeah, unique one.
Yeah. Right. Yeah. So if
wouldn't that be same if you visualize it as the binary search tree?
Mm-hmm.
You visualize it as a binary search tree, and then there's only single element, which is a node. And, the right subtree, that is a list, right? A list of elements, a list of integer there. And we visualize that way, and then that kind of look the same.
Yeah, makes sense. Yeah, but all the implementations are almost this way everyone was discussing. So this would be a unique way of implementing. Yeah. Should try that actually, I would say. Yeah, no problem.
No, we can.
Yeah.
What I used is like, iterated through I used queue actually. So I'll go through every element in the nested list first. And if that is an integer, then I'll try to, this sequence would be a list to which would be appending. We'll pop that from the, from the queue and append it to the doubly ended queue I'm using, append it to the sequence section.
Mm-hmm.
So this is the helper function that I designed. And here your pop left, this next will act as a pop left. That is from the head side, it will start popping the element. And this is just, will return the sequence which would contain your result. And this is a recursive, will keep on unpacking. It will go to the next level.
So you call, when do you call the has next? Do you call it or it is not? It is just called by the...
No, I'm not calling has next. Oh, has next you are telling? No, I'm not calling. Just I'm returning the one which will contain all the elements, that's self.sequence. I think I have not defined that self.sequence is an array. Sorry, this as a queue. I have not defined somewhere.
Okay, your implementation different. Yeah, okay, no problem.
Yeah. Mm-hmm.
So you are just using has next to return the state of the iterator.
Exactly. Mm-hmm.
So the way PS was saying, in that case, I think has next would be required to call every time, right?
Can we see the stack implementation of some?
Yes, sure. Somebody. I'll stop sharing. If somebody can. Just somebody can share. Yes.
Let me share my screen, though. I actually just changed that to accommodate the changes what Leanne just explained. So.
Oh, it's okay.
Okay. Okay.
Yeah. Let me. Do you see my screen?
Yeah.
Yeah. Yeah. Just please increase the font size.
Yeah.
Is that okay?
Yep.
Yeah. Fine.
So let me actually pull what I submitted. So this is what I was doing. So here in the constructor, I was pushing all the element to the stack. And here inside the has next, I'm checking if stack is empty, returning false. Otherwise, if it's an integer, so return true. If it's not an integer, it's a nested string, then flatten that and push the element back to the stack and call the has next recursively.
Nested list will also be pushed inside the stack.
Yes.
Okay. Okay.
Also, the has next, you are returning it, so it will be called again and again in the recursive way, right?
Yeah, so that I can return the correct.
So it will always return true, right? Has next.
No, this line will return false.
That's the base case.
Only if it empty.
Yeah.
Nested string is empty.
So I'm making an assumption that when next will get called, so the top element will always be a normal integer. I don't need to worry about that. What will be my top element?
Okay,
I
so
think,
more processing has next.
Yeah, I think we don't need that recursive call here. Do we?
You can again use the same stack.
Yeah, I think we need that to unflatten.
Yeah, because if you have a nested, so what?
Yeah.
Right. So, but you don't have to call the has next in the next function, because then you are not calling has next at all. If just someone calls next.
Oh, someone called, because this is an iterator, so the user will call that has next, and then they will call the next.
But that is what we are assuming. They have never said that anywhere.
That is a basic. I think it should be somewhere about that. You see
We
that.
assume that the user is a good programmer.
No, you see that. I mean, they mentioned that how that will get used.
Sorry, my bad.
Yeah.
Okay. So yeah, this was a good way of implementing also, because instead of flattening the whole string and doing it, I think that doesn't make sense, right?
Yeah.
As per the interview perspective. Actually, I would say like doing the Leon way would be the best way to do it, but not the flatten way.
Yeah, not the flatten way. So I'm just trying to, I think that's doable. So getting some errors, which I need to see here, but what I suggested that earlier I was just actually pushing everything. So now I'm pushing only the first element to the stack and keeping the track for the list and the index. And here in that has next, I'm pushing, checking that if my list is empty, I mean, the stack is empty and I reached up to the end of the list. So I have to return false. Otherwise, if the stack is not empty, then return just true and top is integer. Otherwise, I'm pushing the element. Actually, here I have to check that. Yeah, here actually I have to check that because I made an assumption. So there are two possibilities to reach here. One is the stack is empty, or or second, the top element is actually the
integer.
nested list. So I don't need to blindly push here. I have to make a check here. If it's empty, then only push, otherwise flatten it.
Okay. So maybe with some tweaks, it will work. Okay.
I believe it should
Right,
it should work actually. Yeah.
You are
It will
missing
require.
two. You are missing integer part. You are missing.
Yeah, I'll have to check that. I mean,
Yeah, no problem. Yeah.
yeah,
I
but
understand.
but I think, I mean, that makes sense, that what Leon just explained.
Yeah.
That makes sense.
Yeah, I think before pushing to the stack, we should check if it is an integer, then don't push to the stack or something.
Well, that's what I'm checking here already.
Because it's a recursive one, so you'll have to be very careful. So yeah.
Yeah, I have to check that. Maybe we may need to actually.
Sure. Yeah.
Check here.
No problem. So if you have some solution, just post it on the Slack.
Yeah, sure. If I'll be able to make it, I mean, come, then I'll share it in the channel. Yeah. Okay, to you, Sasank, I'm going to stop my sharing.
Yeah, sure. Okay. Yeah. So let's proceed to next.
Hey, I have a question, just maybe
Sure,
vague one.
Okay.
So does the ordering matters here, like when we are like pushing into the stack, like, you know, and when it is called a recursive, when it is called by the user using the next function, like how does it print? Does it print like the output will be like 1 1 2 1 1 like in the first example?
Yeah, it should be like in the order that they have given you the input 1 1 2 1 1. You can, all the.
I think order matters absolutely. That is
order of the elements returned by next should be the see they have.
Okay, so wait, since we are using single stack, does it print like the same order? I don't know if I missed something.
Stack, I didn't use, I think.
Yeah, it will print in the same order. So because we are pushing item from the back side.
Oh, okay, got it.
Yeah.
Thank you.
Oh. Yeah, any queries further? Okay, let's switch to next then. Yeah, this max chunks to make sorted. So they have given an array of integers which are not necessarily distinct. We need to split the array into some number of chunks and individually sort each chunk. After concatenating them, the result equals the sorted array. What is the most number of chunks we should have made? So if you look at that example, at whichever point you try to sort them, you won't, after concatenating them, you won't get a sorted array. So they have taken the entire list as one chunk. So at maximum one chunk you can have in order to, because they have chunked at 5 4 and 3 2 1. After concatenating them, this array is not sorted. So, and even if you do at other like this place also, you won't be able to get the sorted array after concatenating. For this, one possible way is like you can sort it at this, but since they are asking you to get the maximum number of chunks, so this is the most best way. I mean, this is the best result. Like if you chunk at this position and individual chunk at this further. So this will give you, after concatenating them, you'll get the sorted result like this. And this is like length will be 1 to 2k and lies in the range 0 to 10 raised to power 8. Yeah, any queries in this question?
So whenever the elements in the array are in the right spot, so they will be a separate chunk. Correct?
Yeah, exactly.
So that is one thing what I got from this.
Like 3 4 4, they are in the right. What do you say? At the right position, right place.
Spots, right? Yeah. So they become a separate chunk. So we have to count them individually. And secondly, when the first example says it's in descending order, so the whole chunk will have to be sorted in the ascending order.
Ascending order, yeah.
So therefore, it will be only one.
One, huh? Yeah, I mean, you can't split in mid. You can't get any place like where you could, after concatenating, you could get a sorted one. So entire list need to be reversed, like sorted and ascending.
Because even if 3 is in the right place, still you cannot use that 3. Correct?
Yeah.
So the way I was saying for the example 2, when actually it's in the right spot, you can actually count them as a chunk, but that doesn't apply for the example 1 because 3 is in the right spot, right?
Yeah.
So because the last
right spot element, in the sense, so right spot you are saying according to index or what?
I mean, yes, index, according to the index. So whenever we sort it, it'll still be there.
Yeah.
So that logic doesn't work everywhere.
Partially it works at some of the examples.
Maybe we, besides checking the index, we also need to check the next index. So the next index, if it's greater than the current one, then that's fine. But if smaller, then it cannot.
But what happens if instead of 2, we had something like more than 4 or so, like 6 there, right? But still we would have to, or maybe 4, right? If we have 4, then we still will have to do the whole string, right? Or
no? No, I think we have to go for
we have to, right?
You mean like a duplicate 4? Can we give an example? Can we write out?
Sure. Yeah, sure. Yeah, say what do I say? Which?
So like if you have 5, 3, the same one, the first example, 5, 4, 3, 2, 1. Okay. So what Leon was saying, if the second element, the element 3, actually is, we need to compare it with the next element. So if that, if 3 is actually now is greater than 2, but if it would have been lesser than the next one, like instead of 2, if we would have had 4 in that place, right, Leon?
Yeah. Right.
Yeah. So if we have 4, we still have to do the whole chunk.
Then the would fall, we still need to look at the next one, right? Can we just write out on the next slide? Can we write out the sequence like already sorted 1, 2, 3 on the next slide? Yeah. So here 3, right? And the next one we see 4, right? So I'm thinking, we need to, if we check the next one, and it in the wrong position, but look at the value is still smaller than 3, then we know that it shouldn't be. We know that we cannot create a partition there.
I think we are almost close to like what I would say, like what like let's say I made one chunk at this place. Okay, sorry. I mean, I'll try all the possible chunks. Okay. So when I did first chunk, I'll get 5. The remaining chunk I'll have 4, 3, 2, 1. Now what I'll do, I'll get the maximum element from here. Okay. And minimum element from this list. And if the maximum element here is greater than the minimum element of the is less than the minimum element of this, that means after concatenating you'll get the sorted array. Does it make sense? Like let's say, I'll tell you.
Yeah, you take the second example.
That will be better.
No, but actually first let us actually get to the point what Leon was saying.
Yeah.
So he had something different, right? Yeah, Leon?
Yeah. So we write under that 1, 2, 3, 4, 5, right?
You just make that sort, create that 1, 2, 3, 4, 5.
Okay.
Yeah. So we see 1 is not in the right place, 2 is not in the right place, 3 in the right place, right? And then we check 4 is not in the right place because we see the 2, the right element next to 3 is 2, which is smaller than 3. So we know that we cannot create the own partition at 3, right? Because 3 have to be, if we create our own partition at 3, mean whatever on the right of 3 have to be greater than 3. But now we see on the right of 3 it's 2, which is smaller than 3, then we cannot do it.
Yeah, so in that case, if you are just comparing each element, what I was suggesting, if the string input would be like, have been like 5, 4, 3, 4, 1. Okay.
Yeah.
So in that case, Leon, see your logic of when you are comparing 3 with the next 4 would work, right?
Yeah, the next one work, but the next to 4 is not, right?
Okay,
next
so
to 4 is 5. So
okay, so you go to the last one also.
Yeah, I will keep going.
Okay. Then that
but that's my thinking. I don't know how, if it.
Yeah, that is also one way. Yeah, Shashank. Yeah, you go ahead, Shashank. Your approach.
Yeah, what I was doing is, let's see. I'll try all the possible chunks at all the possible points. So like, let's say first I tried with 2, the remaining will be 1, 3, 4, 4. Now just I'll check the maximum element on the left side. Here it is 2, and the minimum element on the, I think 2 is on the left, sorry. So maximum element on the left side and the minimum element on the right side you check. Minimum element is 1. So 2 is less than 1. Sorry, 2 is not less than 1. So once you start merging it, then you'll never get the array sorted one.
Okay,
Yeah,
so in that case, what you do?
In that, I'll go to the next chunk. Then I will take this element, go to the next, this spot I'll try.
Can you actually take that again? Yeah, go down. Yeah, keep that same way. 2 greater than 1.
Okay, 2 is great.
Yes.
So Shashank, if you merge them, why don't you get a sorted one? Because I thought when you merge, you will merge as a sorted array. Oh, merging is just concatenating, is it?
Yeah. So that is not,
like
they
merge
just
sort merging
chunks.
Yeah.
Oh, okay.
Now if I take, let's concatenate, merge at this spot. Now you'll have 3, 4, 4. Now minimum element, maximum will be 2, and minimum will be your, on this side is 3. So 2 is less than 3, right?
Right.
So now if you concatenate them, if you merge these two,
first sort and merge. Okay.
Merge, and 2 will come, 1 will be also there. And after that, the left part, what you say, the right part is already sorted.
Yeah, but 1 and 2 you'll have to sort, right? First.
Yeah. This left part, I have to sort it and get the maximum one. That is what I'm saying. Yeah.
So that chunk works. That is what we're trying to say. Whenever the left one, whatever is the maximum element in that left, if it is lesser than the minimum element of the right.
Exactly.
So there you can form a chunk. That is
exactly.
Okay. That is okay.
One chunk, that
is.
After that, again, you can proceed for this. So if you proceed here, you'll have, again here, maximum you'll have is 3. So 3, and here minimum you'll have is 4. So again, one more chunk you got. Let's say now you had 2, 1, 3, 4. I mean, it should be equal to also, it matter. I mean, not strictly less than, even if it is equal to, you can.
Less than equal to, okay.
Yeah, less than equal to. Here also same thing. Maximum would be 4, and the minimum here would be 4. I mean, both are equal. So when you merge them, you'll get
so that will be the 4th chunk, right?
4th chunk here. One chunk, this is not a chunk. 1, 2, 3,
and the last one.
Last one, 4.
Okay. So the reason that we look at the max on the left.
Max from left,
yeah, and the mean on the right. Is because at that point, at that index, we guarantee that it is sorted. We can think at that index, it's like a pivot point in the quick select. I think, right? Because all the elements on the left are smaller than that.
Pivot.
Yeah.
Right, correct.
And all the elements on the right are greater than. So we know that we can form a partition there. Yeah, I think it worked.
Makes sense, yeah.
And the other approach is like, that's more simple, I think. Simply you sort the first array. Let's say you had 2, 1, 3, 4, 4. If you sort them 1, 2, 3, 4, 4, and just what you do, take a reverse of it. If you reverse them 4, 4, 3, 2, 1, make it in any separate array, and this is your original array. Just check, you start summing each of the elements. Like this is initially sum is 1 and this is 4. Since sum is not equal, so increase the moment you find that sum of this side and sum of this side are equal, that could be also one point of chunk. That could be a point where you can.
Oh, so you are trying to take a cumulative sum.
Cumulative sum,
of both the arrays. So whenever the sum is same, it means that you can have a partition.
Partition, exactly. I think from this side you'll have to go from this side for the first array and for this from back.
But you can do with only single array, right? The main array and with one of them are sorted.
No, both are sorted, but one is reverse, the other is normal. Like this is the
that is
array.
also there, but you can do it with one sorted also.
Yeah, one sorted. You have to use pointers then, I think. 1, 2.
No, in the first one, if you have like 2, 1, 3, 4, 4, and just the temp one, can you just okay, create one more here? 1, 2, 3, 4, 4. Sorted one.
1, 2, 3, 4.
4.
Oh, sorry, 4.
Yeah. So now you start from the first element. You have like sum 1 and sum 2. So sum 1 will be the first array 2
is 1.
And sum. Okay.
Oh, go ahead.
Can you just write sum 1? Yeah, sum 1 currently is 2. And then on the next line write sum 2.
Yeah.
So which will be equal to 1.
Yeah.
Of the second array. And now when you go to the next one, next
4.
element, so like you add 2 plus 1 here, that will be 3.
1, 3. And this will
and then you go for here, so
2.
1 plus 2, right, will be 3.
So this is one chunk.
So yeah, whenever you have both the sums together, this will be one chunk.
Or you can also do one thing. You can take the cumulative of this and let's say cumulative 4, 4, 8, 3, 11, 11, 13, 1, 14. You got the cumulative sum, right? Now for the left array you can take 1. For the right array it will be 14 minus 1, 13. No, it won't work. It won't work. I think that I was trying that first element. If I took the remaining sum will be the 4, but that it won't work here.
Yeah. So this will be a simpler way of doing it because it's very easy to even remember it. But the only downside of this is it needs a sorted array.
N
log n. And the way you are describing will be more efficient because it doesn't require a sorted array there. Correct?
Yeah, one pass you have to go, I think.
Yeah.
So I've used both, I think.
So one thing I wanted to check is that the chunk has to be the sub array of the original array, right? We cannot change the order of the element, right?
Correct.
Yeah. So the way I was thinking about this problem, like instead of doing what we are trying to find the min and max, suppose if I take an example 1 or 2, suppose I start with 1, right? And then actually I was thinking in terms of pancake sorting here, where you take a 5, right, in example 1, and then you try to find the number which is greater than 5 in the array, right? Which you will not find here in example 1. So this will become your one chunk. But if you take an example 2 and start with 2 and then try to find an element which is greater than 2, right?
Yeah.
So you find 3. So
immediate greater or any greater?
immediate,
Okay.
any greater is fine.
Okay.
I'm not sure like whether it will handle all the cases, but the way I was thinking, given the example, is that
can you want to share your whiteboard or something?
Yeah, you can share it. If immediate greater you are saying, then this is converges to same my approach what I was saying. Like, okay, you can share this.
Let us see what it goes.
Yeah, sure. Okay, share it.
Yeah.
Okay.
Okay, do you see my screen?
Yeah.
Huh.
I mean, I'm not used to this, but just trying.
It's okay.
Or you could write in that lead code also, maybe on Notepad, Word document, something. Yeah.
Okay. Yeah, let me do that. Yeah, let me share my different screen so that. Yeah, do you see my screen now?
Oh.
Yeah, so the way I was thinking is I have this as a number, right? So I start with 2 and then try to find a number which is greater than 2 in my array. So in this case, I'll be finding 2 and 1, right? I mean, I'll find 3, so my first chunk become 2, 1, and then I start from, so this become my first chunk, and then I start from 3 and then try to find a number which is greater than 3, right? And I find 4, so this become my one chunk, greater than or equal to, right? And then I go to 4 and traverse further and then try to see 4 is my next number, right? So this become my one chunk. I'm not sure right now whether it will handle all the cases, but I was just thinking in terms of pancake sorting, right? Where you try to pick a element and then try to see any element which is bigger than that element, and you go to till that position, and then you find you have to rotate or flip that array, right?
Yeah. So what if, like, can we give an example, like, after 3, there's a 0 there.
Yeah, 0. Huh?
Yeah, 0 and then 4, 4.
Okay. So you start with 2 and then you go until 3 here. So this becomes your one chunk, right? And then you you take 3 and then try to find a number which is greater than 3. So this becomes your one chunk. So it becomes like this. And then 4, 4.
No, it won't work in this case because you would need 2130 together at least.
Sorry?
You would need 2130. One
together?
chunk. Yeah. Because because 0 is the first element, right? So it has to come.
Beginning.
It has to be, come to the first position, right? Yeah.
Okay.
Yeah, I think this is like the monotonic stack way also of doing it, right? Yeah.
Okay.
Yeah, this is a good one to actually keep.
Can't we use stack directly? Like start pushing the element the moment we find any element. No.
Sorry,
I was telling that we'll start pushing the element inside the stack. Let's say first 2 I'll push. Now next element is 1. Since 1 is less than 2, so we can't make a chunk at 2,1. But
yeah, but 3 comes, right? So then that is the bigger one.
Yeah, exactly. That's it.
So we use it if like at 2, right? We look for the next greater element at 3. Yeah.
So,
Right. And then
so here in the question, 0 is not a valid entry.
Oh.
Yeah, but then we can have something else, right? We can have
less
one
than, less than, I think that's what he meant. Like less than, suppose it is.
Oh, no, sorry, my bad. I mean, it has actually the array size itself.
Yeah, even if 0 is not there, still, if we have something lesser than that, then it might be a problem there. Yeah.
Yeah, true.
Okay. So we have limited choice, it seems.
Yeah.
Okay.
Yeah, can we go back to the previous one? And I'm not understand why when the sum are different, then we have to make the new chunk.
If sum is same, then we have to make a chunk.
Yeah, when the sum, can you explain why?
Yeah, in that case, like, okay.
Let me go through directly.
So because what happens when you are sorting?
Yeah, go ahead.
Yeah, when you're already sorted, right? So whenever you have a sum same, it means that they are almost sorted.
The same. Okay. When you mean almost, what does it mean? Like,
both of them are same actually.
Okay.
Both of them are same. So if that comes only when till that part, the whole of thing is sorted, or as one side of the pivot.
Yeah.
Right.
Yeah. Yeah. Right.
But the only downside is we need a
sorted array. Login.
Yeah. Therefore, it's n log n solution. But the one what Shashank described and the way he is implemented is slightly difficult to get anything about it. It's not very intuitive.
I did it like I'll share the code. What I did is just I ran through the first entire array and calculated all the max from right to left to right. Like
okay.
Yeah, and then again minimum from right to left. Just reverse the array, and this is what I performed. Like whenever you find the element greater than equal to, this is to make sure that after concatenating it, you'll have a sorted one. That's why I'm using this. So you can, I think, yeah. Is there any doubt in this implementation part? Okay.
This is the one you sort them?
Pardon?
Is it the one you sort them? You sort the array?
This is not. That is another one. This one is the what I was saying. Someone.
Okay. Yeah.
Yeah. I created I copied the array, sorted them, and just initialized to sum to 0. And I'll walk through the array. I just check it temp sum. Each element we add to the temp sum and the array, and just check wherever you find the sum is equal. You can make one chunk over there.
Okay. So the other one is pick of n. The previous one you show.
Previous one, yeah, I think it should be order of 1 only, or order of n, because one for loop here, another for loop here, and one for loop here. Yeah, order of n, order of 3 and order of n.
But you could have avoided the third one. Third for
this
loop,
one.
right?
Yeah, we could.
Yeah, you could have actually done it in the second one.
I have to take 2 variables. I think max so far I'll check like. How do you say that to avoid it? Like.
So whenever you have, you actually you're trying to compare the minimum with max from left, right? So minimum from right, actually you can just have a variable over here and keep on finding the minimum and just compare it in the second for loop.
And
if
update
it is less than or equal to right with the index.
Yeah.
Right. And then just increment the chunk.
Okay.
Maybe you don't need the another array on line 13 too.
Right.
Because we keep track of the mean so
one array
far.
should be fine, right? Yeah. Either you have a min or a right or a max one, either of it.
Okay.
Yeah, but this is a very easy way of understanding.
Yeah, I mean, bit intuitive, like.
Yes, to some certain extent, sure.
Yeah. And they can have duplicates also. Yeah, we had discussed. We had duplicates.
Yeah, but this problem is really not so easy to understand.
Yeah, they have used some sliding.
Yeah, sliding window, that is also.
Grading approach.
No, I didn't try the sliding one. But the sliding one has a sorted array, so it might be more.
And log again.
And log n, yeah. Even I think the second approach, sorted count pairs, that also is n log n.
I think it's n log n only.
And also it is using extra space.
Extra space.
So the one what you implemented is much better than both of them.
This will be order of n. Yeah. So any queries further in this?
Yeah, no.
Okay. Then can stop, right?
Yeah, stop recording.
Okay.